Hello. I'd like to talk to you for the next few minutes about the Galarath tool called Sear for Manufacturing. Sear for Manufacturing is an effective, world-class tool for estimating parts or products to support your needs, whether they be internal needs for manufacture, whether they be external needs for where you're negotiating with clients and suppliers. Sear has a number of interesting additions to their tools, not the least of which are what we call our CAD to cost tools. These CAD to cost tools make estimating much more quick, much more accurate, and much more effective. Um, you can introduce a step file, and in a few seconds, you can create an estimate for machining that part. Um, it takes the muss and fuss out of interrogating drawings and entering them into the Sear manufacturing tool. We cover not only machining, but inside the Sear tool, we will cover additive manufacturing, machining, composites, and sheet metal, all of which take a step file, very quickly give you a Sear estimate the way you would like it. We have a similar tool based on CATIA that's designed for design engineers so that they can get instant feedback on their part costs in a similar fashion. Um, we can do turning and machining. We can do machining operations. We can do sheet metal operations. We can do composite operations, all on the desktop inside Sear, inside CATIA, so that the designer never has to leave his work area, can get instant feedback on what his design decisions are driving into the cost of a part. What I'd really like to talk to you about to you today is the engine that sits behind both of these front end tools, and we call it Sear for Manufacturing. Sear for Manufacturing is as I say, the engine that creates these models. The desktop for Sear for Manufacturing may look a little complicated, the graphic user interface, but it isn't really. And I'm going to spend the next little while talking to you about what Sear for Manufacturing is, how to use it, and what you can do with it. Begin with the desktop. It is laid out in a very logical fashion. It's got the ribbon up on top, has a number of different tools that are available to you. Most of these tools are also accessible with the right mouse click to bring those things up. I tend to find those easiest to use. But for the time being, let's take a look at the Sear desktop and see what Sear for Manufacturing offers. This first window on the left, this is your work breakdown. You can make very complex indented bills of materials, indented work breakdown structures for these things. And typically, a top level assembly will require some assembly, and it will require a lot of parts. It may look onerous, but it's really not. Many people just use the engineering bill of materials to go ahead and create their structure. The next screen on this is your report screen. We have a bunch of different reports available for you. You can look at many different things to your needs. The most important of which I think is called the Quick Estimate Report. And there is a lot of information that is updated as you build your model to show you things like material costs, tooling costs, labor hours, unit costs in all kinds of different ways. And there are even able to create your own custom cost categories to track the things that you want to. The next screen is what we call a report screen. Our what we call our graphic screen. Shows you what your cost allocations are. There are risks that are associated with many of these things to tell you how you work those. There's cost contributions. There's operation details, operations analysis that are available at the individual work levels. Shows you where the costs are being incurred inside your model. I think it should be pointed out, this is a process-based estimating tool. Each and every process that you assign to a particular subassembly or to a particular part gets costed individually. It'll tell you what your material costs are, what your setup costs are, what your hours are, what your material costs are, and your total labor costs. So each and every one of these work elements will tell you how much it should cost you. One aspect of the quick estimate screen is you're allowed to do what we call trade studies. So you can come in very easily and set a reference and then change something in your model and see immediately what the cost impact is. That cost. In this case, we cut our costs 8% when we change the quantities. Let's go into some detail here then on the ribbon that we have. In the home ribbon, there are a number of different items that you can select. Most of these set up how you're looking at things, lets you copy, lets you do recalculations, lets you undo, redo when you make a change. You can insert work elements, which is down here in your work breakdown structure. You can delete work elements out of your work breakdown structures. Each and every work element here has a note. This is a great way to keep track of what your estimates assumptions were. If you want to attach files where you have quotes, where you have calculations, you can go ahead and insert those here. Each and every work element has one of those things. The work elements. This ribbon menu item allows you to insert new work elements. You can insert a work element there. You can insert any of the work elements this here covers. You can delete work elements. You can load things called knowledge bases. We'll touch on those in a few minutes. You can expand or collapse, branch. You can also do that right here from the menu. You can look at the attachments you may put on there. You can look at the properties. If you have a scenario, you can insert a scenario. We can talk about those a little bit later as well. You can merge parts into a top-level assembly at this part of the parameter screen. One of the most effective things is to change multiple work elements. You may want to change very quickly what your production quantities are. I'm going to turn this off because it's doing a Monte Carlo risk analysis. Every time you do that, it's giving you a risk curve on this thing. You can lock parameters, you can unlock parameters, you can hide parameters, not hide them. We can do expressions inside each of these things. We'll talk about those in a bit as well. You can edit assembly details, and you can highlight things. If you want to flag this for whatever reason, you can flag these work elements. In the work elements, this is how you structure this. You can insert them, delete them, exclude them, reload them, promote them. When I talk about promoting in these, I can promote those so that now they're at the same level as the carbon graphite body, or I could demote them, move them down underneath so that I can set my work breakdown structure up as an indented work breakdown structure. I can move this up, move this down, put this at a different level. That's what these keys do. You can also just drag them to where you want them, and they'll do the same thing. Tools, there's a calculator that's available so that you don't have to go offline, go onto an Excel spreadsheet or anything, call up a tool. Many reports are available. We have got many different kind of reports available for you. If you don't like the reports that we have produced for you, you can go ahead and create your own using anything that SEER has to offer, any of the information that we've got in there. You simply drag it on and save it. You can save these things on the clipboard, paste them into an Excel spreadsheet. You can create a report that will show up in this window. You can look at just the current work elements, or you can look at the entire project. You can export them to a file in a variety of different formats to meet your needs, to import them or export them to other applications. Charts, we have a wide variety of charts that you can select. Cost analysis, cost risk, sensitivities, cost contributions. These are just what I like to use. Monte Carlo risk, of course, is in there. Importing and exporting. You can export these commands and run them from a command processor. Take them into a text file, take them into an Excel spreadsheet. You can do flexible exports, which is very much like the reports. The options screen. This is how you set up your main configuration. You set your project parameters for such things as your performance. What year do we want to report in? How many Monte Carlo iterations you want, whether you're working in imperial or metric. What kind of precision you want to see in your reports. Custom outputs, if you want to create those in a Excel spreadsheet, you can create those in this screen here. Let you do things like find user specified passes. You can look at the direct labor rate details, use the inflation tables, set up learning curves the way you want them. These things all get set in your project parameters. When you have this set the way you wish, you go ahead and tell it to save that, and it will always be available to you when you launch SEER. Recalculation on your charts, configuration files, where things are, where you store your projects, where you store your scenarios, where you store your knowledge bases. We'll touch on those in a bit. Where the program file is stored, where your initialization files are stored, where your inflation tables are stored. We have a database package that's available to you. It's something you set up to support your needs, but SEER for manufacturing will integrate with those things if you need them to. Views, this is a different ways of looking at your project, how you do the outlines, what the icons are for your work elements, whether you're looking at assembly details, machining details, notes. Those things are all available here. As I say, most of these things are available with a right click from your mouse, so they're easy to use. So what we've looked at here now, we've looked at how you structure your program. We've looked at some of the reports that are available for your program. We've looked at the charts that are available for your program. And we get into this screen. This is where much of the work really gets done inside SEER for manufacturing. There are what we call the general tabs. There's the process specific tabs, the tooling tabs, the inspection, rework, mark and package. Every individual process inside SEER has exactly the same tabs. And for the most part, they are virtually identical. The general tab, this is where you go ahead and define what your production quantity will be. SEER's very sensitive to things like setup. So as your production quantities go down, your costs go up. Whether you want to amortize your setup, how many parts you want to do that on, your hourly rates. SEER has a great many rates that you can choose from. We have what's called a labor rate calculator built in here. And for each and every process, you can choose either the labor and equipment, or you can choose the company that you're looking for. We have many of those built in. They're very accurate. In addition, you can choose to work this process if you were going to assemble them, say, in Mexico or China. It would be very easy to do that, and SEER would go ahead and calculate them not only in the local prevailing labor rate, but with the exchange rate applied. So we've got good, accurate information on manufacturing things virtually all over the world. These are either project specific, you can set those at the project level, or you can set those if you don't like our labor rates, you don't have to use them. You can put any kind of labor rate you wish inside these labor rate calculators. Tooling. SEER for Manufacturing will give you good tooling estimates for the processes that you're looking at. We have a great many tools that we have costed through these things. You can define what sort of tools you may want for this assembly, and it will go ahead and cost that tool out for you. This is a growing list. You can just continue to add those if you'd like. Handling fixtures, machining fixtures, clamping fixtures, welding fixtures. It will go ahead and it will calculate those things for you. That's what we'll add for you. Inspection and rework. SEER has built-in computed values for these processes. It comes off our databases, tells you what your percentage of inspection based on your direct hours. It'll also calculate a percentage of rework based on direct hours. If you don't like the numbers that we offer you up, or if you have better information, you can always change these numbers. A simple double click. You can put a range in those things. It'll give you a cost curve, it'll give you a cost risk curve based on the range. If you have better data than we are offering, please use it. We include a great many non-destructive testing operations here as well. Pulse echoes, dye penetrance, x-rays, manual CMM, CNC CMM, a great many different non-destructive inspection tests for these things. And again, this is a growing list. You can add as many of those things as you wish to get your product inspected the way you want it to have it inspected. Marking and packaging. Each and every work element includes a marking and packaging. We include many different kinds of marking and packaging. In marking and packaging, we've got metal stamping, we've got adhesives, we've got barcodes. All of those are already worked in there. Again, a growing list. You may have to make many different mark and package operations here. Packaging, surprisingly, packaging can be very expensive. We cover a great many different kinds of packaging that you may need for this. Again, this too is a growing list. So what we've discussed here for a moment is the general tab. We've discussed the tooling that you may need to do these things. We've discussed the inspection and rework, and we've discussed mark and packaging. These are all common to every different manufacturing process that we're offering up here. We call them common parameters. The real work gets done in this screen right here, what's called our process specific. I'm going to go ahead and change and show you what kind of processes that Sear for Manufacturing offers you. So this is a blank screen for Sear for Manufacturing. I've set up a work breakdown structure that is sort of representative of what you may see. You've got your top level summation. That's what this summation sign means. Everything below here is being summed into this top level cost roll up. This is being summed, everything below it in the cost roll up. So a typical work breakdown structure will have a top level assembly. It'll have a roll up of some sort. There'll be sub elements associated with that thing. There's probably some assembly that goes into all of these things, and they'll all roll up into a top level process. What kind of processes does Sear cover? Let's spend a few minutes on those right here. Machining. Sear for Manufacturing offers many different processes, just about anything that any manufacturing organization could need. Machining probably being the most popular. When you look at the process specific in machining, it's going to ask you a number of different questions. First and foremost, it's going to ask you, what kind of raw material do you want to use? There's a lot of selections in the raw material. Typically, it's a wrought material. It'll ask you for the dimensions of your material. Since I've given it a rectangular piece of material, it's going to ask for the length, the width, and the height. Had I told it was a round solid, it would be asking me for the diameter and length. Enter those things in there. That tells you what material we're starting with. It's going to ask you what your material of origin is. We cover a lot of different kinds of material origins, from raw stock material, to all kinds of castings, forgings, or additive manufacturing. You can choose one of those as well. So we'll go ahead and continue to make the calculations based on what you told it. Sear for Manufacturing has a great many different materials that are included as part of our initialization file. These initialization files are very easily modified to suit your needs. The values that are in these things are representative of what you can expect in the industry at large. But if you're a smaller manufacturer or a giant manufacturer, you may get a very different price on aluminum alloys. And the price for aluminum alloys is coming out of this INI file. Very easy to edit the material INI file. We give you instructions. Every single screen inside Sear will have this little button that says More Help, and it will talk about all of these things. There's basic information throughout there. There's information on just about anything you want to find inside Sear. Right here, there's tutorials, there's references. We talk about server modes. All kinds of different things are included in this. Well documented how to use Sear for Manufacturing. The cost per pound is populated from your INI file. Material utilization files, factors. You may want to assume 5% scrap, 10% scrap, 20% scrap. Here's where you would enter those values. And anytime you see 3 boxes like this, what you're doing is you're building uncertainty into your estimate that'll later show up as a risk curve, a range of values on your estimate that you received. That reasoning factor, tax factor. Machining, here's where we come into the different processes that we cover there. And I should point out, each and every one of these high-level processes includes many, many lower-level processes. In machining, for example, you got radial milling, end milling, chemical milling, grinding, reaming, tapping, thread milling, cutting, honing. All of these things are robustly supported with good data, good traceable data, that'll give you a very accurate estimate of your costs. Additional items. Almost every element here includes an additional item, where if you come across something that we don't necessarily cover, you can go ahead and create your own estimate on those based on your knowledge. Might be a special test. You may have to do that on every part. There's a setup associated with it. There's a direct minutes associated with it. There's inspection time, rework time, material costs, tooling costs, etc., etc. Not only is this available in virtually every work element, but it is available as its own work element doing the same things. So what I'm showing you here is I'm showing you the different fundamental processes that you might invoke to create an estimate. We covered machining, fabrication, electrical assembly, mechanical assembly, or not only mechanical assembly, but welding and brazing and riveting and staking, bonding, hoses. Again, you see the additional items sitting here. Electrical assembly, you can build cables, fiber optic cables, or harnesses. On and on and on. Molding, castings, forgings, PC boards, finishing and heat treating, additive manufacturing, tube fabrication, purchase parts. If you're just going to buy some parts, very easy. Enter them in there, becomes part of your estimate. User-defined additional items. Composites. We have probably the best composites estimating around. Very simple to use. Define your part. Load in your ply tables. Load in how you're going to cut them, how you're going to label them, how you're going to kit them, how you're going to cure them, how you're going to trim them. If you're going to bond them later, we make provisions for those things. We have a very robust sheet metal process. What we have done is we've taken a set of data that includes both fabrication and finish and heat treat, and incorporated those all with special aerospace data that makes it very simple to use in one process screen, where you define your preform operations, your forming operations, your after trim, after forming operations, and your detail finishing operations. Fit up. This is a special group of parts for aerospace manufacturing. The aerospace assembly process typically involves dry fitting parts together, measuring gaps, shimming gaps, putting sealants in, drilling through the assembled parts, and then installing fasteners. We've broken that into three different sections to reflect the aerospace manufacturing process. I know this seems a little onerous, and it's a little bit difficult to get your brain around here, but let's just quickly take a look at what a SEER for manufacturing project looks like. When you open up SEER, by clicking the icon, you will get this screen. And if you're starting a new process, you'll go ahead and you will tell it you want to create a new estimate. You'll name it. You'll put your name on it. You'll decide whether it's going to be imperial or metric, which year you want to be producing this in. It'll put a timestamp on there, and you simply tell it yes. And what you'll see is this very top level summation. I've named it demo. To create an estimate, I'll use the right button methods for these things. You'll insert a work element. And just to start this off, I'm going to call it a level 1 part. And I'm just going to insert that. Notice it's demoted, and I've begun to create a work breakdown structure. This level 1 part might be a machine part. So I would insert a work element here. I would call it a machining part. And one of the things that SEER has that makes this very convenient are things called knowledge bases. We've given a lot of samples of different kinds of knowledge bases. What a knowledge basis is set of preloaded values so that you don't have to populate each and every field tied to. You'll notice that what's happened here is it's already pre-populated my labor rates. It's pre-populated my calibration rates. It's started to lay in some operations steps already. What it's really looking for from me are my raw dimensions. Now, these knowledge bases could be anything. You could have defined those as a specific machining center, a supplier. It could be an overseas estimate that you're going to create. So it's all set up for Mexico or China or Turkey or wherever you want it to be on these things. It'll have the material already chosen for you. It'll have inspection and rework already set up for you. It may have marking and packaging. Whatever is specific to what you're trying to accomplish, you may create those. I'm going to hit this demote to make sure I took it in the level 1 part. You can see it's become subordinate to the level 1 part. So what I've done is I've just created a machining work element under this first level part. After I'm done machining, I may insert a work element for a heat treat. Oftentimes you'll have to go ahead and after you're done machining, you'll have to heat treat things. When I tell it to copy common parameters, it will copy all of the things that are in the general, the tooling, inspection, rework, and mark and package. So I've just now created a heat treat work element for this thing. Heat treat work element could be just about anything. Typically, what I would do is I would do a heat treat on this. Steel. Oops. Do a heat treat. I'm going to load it and unload it once, and I'm going to harden. When I'm done hardening, I may want to go ahead and do a passivation on this. Maybe I'll gold plate it, or maybe I'll just passivate it. We've got data for all of that. So the way you go ahead and build up these estimates for this are to just add different processes, just like you would if you were making a manufacturing plan, in creating an estimate. Let's talk for a minute about, why don't we do a real estimate here for a moment. Let's close this down. Don't want to save it. We don't need that anymore. Let us start a new estimate. Let's pretend that we're going to make a gear. Let me show you how simple a gear is. Typically, you'll get some engineering information that will tell you what the gear's performance parameters are. I don't have any of those right now, so let's just assume that I've got a 40-tooth gear here. That might be right. It's going to be about a 2-inch pitch diameter. It's going to have a 1/2-inch bore, and I'm going to have a slot here for the shaft. Bore is going to be a fairly high tolerance on this, so that it fits easily on the shaft. So let's create a new model to do that. From our SEER, let's do a new estimate. Let's call it a gear. Do it in US dollars, do it in 2021 dates. I'm doing it. Okay. So to make this gear, I suspect we're going to start with something that might be a 2.5-inch diameter piece of stock, 1 inch thick. Perhaps it's a bar, we're making many of them. So let's just start with a 2-inch round stock out of some sort of alloy steel and see how quickly and easy it is to make an estimate. Remember, you've got 20 teeth, 2-inch pitch diameter, 1 inch thick. Let's insert a machining up. Insert a machining element. Your machining. Okay. Let's say we're going to make 100 of these. Let's use the SEER default labor rates. Let's do a labor calibration. What labor calibration is effectively utilization, or the inverse of utilization. If you run 1.2, that's typically an 85% equipment utilization. We're going to be looking at the 50th percentile probability cost on the cost curve. Let's go into the process specific and let's start laying this in. We're going to be using a raw stock. We're going to use round stock. We're going to do lathe cuts on this thing for the most to start with. There's going to be a round solid. It's going to be 1 inch long and 2.5 inches in diameter. Okay. It's going to be an alloy steel. Okay. We'll talk about our operations. First thing we're going to do is we're going to turn this. We're going to go ahead and we're going to rough turn this. And we're going to turn it to just a bit over the 2-inch pitch diameter. In the engineering drawings, it will have told us what the major OD is. So we will just go ahead and turn a cylinder off this, turn a tube off this. We're going to start at 2.5 inches in diameter. We're going to cut it for 1 inch. And we're going to end at 2.1 inches. We're going to set it up on the machine. We're going to load it in the machine. And there we go. We started to build cost in these things. Okay. I noticed this red thing. It's telling me that I've got a tooling estimate in here. I don't really want that right now. This is going to be simple enough. I don't want a tooling estimate. So I'll turn that tooling estimate off. Go back to my process specific. After I've turned the major OD, I'm going to do a process called hobbing. Gear hobbing. And we're going to hob the gears. We decided we're going to have a 40-tooth gear. The width of the gear is going to be 1 inch. The diameter of the gear is going to be 2 inch. The pitch diameter where the teeth ride on one another is going to be 2 inch. The hob diameter should be approximately the same as the pitch diameter. This one doesn't have a helix on it. It's going to be a straight gear. The teeth on these things go straight fore and aft. We're only going to do them one at a time, and the operator is going to sit there and watch it. He's going to have to set this up and load it and unload it as well. So we've turned the OD. We've hobbed the gear. Oh, one thing we missed. We're going to have to put a bore on this. Let's look at the center bore on this. I'm going to call this a 1/2 inch diameter. Excuse me. And it's got a slot in here for keyway. So let's go ahead and create that slot in that keyway. One thing about SEER for manufacturing, it doesn't care what order you do these things in. All it's really looking at are the materials and the labor time to do it. So let's go ahead and put the bore in here. Let's do a rough bore. Now, in roughing operations, typically what SEER is looking for how much material you're trying to remove. In our case, we're going to go ahead and we're going to take out a cylinder out of the center of that thing. It's going to be a 1/2 inch diameter. It's going to be 1 inch long. We'll bore that through. We don't have to do a setup because it's still on the lathe from the OD turning. If I want to keep this, well, I'll show you how to do that in a moment. Next thing we're going to want to do is we're going to do a finish bore. Finishing operations typically talk to a surface area of some sort. In our case, we're going to give it a surface area dimension. We're going to give it a 1 inch length. We're going to give it a 1/2 inch diameter. Here's where you get the opportunity to set your finish. Bores like this typically have a very high finish, and they will typically have very close tolerances, something on the order of 1 or 2 thousandths, so that they fit snugly on the shaft and don't rattle around. We'll put a finish boring operation in there. Got to go back and do that, see what it is. At this juncture, we've got turn the OD on this thing. We've done a rough bore, we've done a finish bore. We'll need to go ahead and broach a slot in there for the keyway. So we'll come down here and put in a broaching operation. We're going to put a 1 inch length, broach the slot. We're going to get it in one pass. Use a carbide tool, flood coolant. We'll broach the slot. I'm going to go ahead and realign my processes here just so that they make more sense. So I'll just copy those. I'll paste it there, and then I'll delete that. So now you can very easily read down what the manufacturing plan looks like. You're going to turn the OD. You're going to put a rough bore on it. You're going to put a finish bore on it. You're going to broach the slot. And you take it over the hob. Our part's machined. Next thing we might want to do is go ahead and heat treat it. So often these things are hardened. I'll put in a heat treat process. I copy the common parameters, which means everything that was in there before. Put it in at the same level before. Now I have a heat treat process defined. Notice it's already populated with how many parts I'm going to make, with what my costs are going to be per hour, tooling, inspection, rework, marking, and packaging. I haven't defined any of those yet, but let's put in a heat treat process here. So we're going to heat treat this thing. We're going to put it in once. We're going to harden it. No fixturing required. Okay. We're making 100 of these. So our batch size is going to be 100. It's asking me for a weight. This isn't a big driver on the cost, but let's go ahead and find the weight. If I look at my gear machining, one of my readouts in this is my finished weight of 0.93 pounds. So I can go in here, and I can go ahead and fill out 0.93 pounds. And now I've got 58 cents a piece for my heat treatment. I've got heat treated. After they're heat treated, you may want to do some inspection. In this case, we may want to take a look at, do a dye penetrant inspection on this. So we'll put a dye penetrant to the cracks in this thing. Part area is going to be 3 square inches on each side, which is 1 inch radius times pi. So approximately 6 inches total part area on this thing. We're going to go scan it. We're going to look at 100% of the surface area. We may have to reinspect 5% of this. But now we've got a dye penetrant inspection on this thing. When we're done, we want to mark. We may want to part mark it. We may want to engrave a part number on it. Use an electric pencil. Let's go ahead and engrave a part number on this thing. And let's package it. There is class. We just created an estimate for the gear. Our average production unit cost on these things is going to be $14.66. Now, if I was selling them and wanted to add some factors, I may want to get a 5% profit on the materials that I'm using and a 15% profit on the parts. The labor, I think, has already been taken care of with the labor rates that I've used. And so I'm looking at a $16.92 gear. It's that simple to make these kind of estimates. We could do them on just about anything, as I say. If you look at the SEER for manufacturing, it has all of these different kind of features. I could have done in about that amount of time. Could have done some electric harnesses, fiber optic cables. I could have assembled things either by welding, brazing, adhesive bonding, could have been gas-work welding, could have submerged arc welding, stir welded. SEER just has a wealth of processes where we have very accurate data for how to do these processes. So I hope this was informative to y'all. It might look a little overwhelming, but it really is not. The interface is simple. I think anybody that once they get familiar with the interface, with any kind of background at all in manufacturing or estimating, you can make very quick, very accurate estimates inside the SEER for manufacturing tool. Thank you again for joining us, listening to me, and if you have any questions, be sure to call Galrath and ask for some help. Thank you very much. Bye-bye.